Hello my dear students, welcome to SHLOKA'S Academy. In the last video we have discussed up to atomic mass unit, that was AMU, and we have done all these things. Up to here we have completed. Now today in this video I am going to start from here, and I have given three examples for the atomic mass unit. If I take a hydrogen, which is 1.008 atomic mass unit, that is AMU, and oxygen 16 AMU, and chlorine 35.453 AMU. Just keep these values in your mind. So let us come to this one. Actually, most of the elements, right, their atomic masses of most of the elements, if you take atomic masses like in the previous slide, oxygen, hydrogen and chlorine, most of the atomic masses are not nearly whole numbers. Why? Because whatever the atomic masses we have written, that was for hydrogen or chlorine, they are not actually real atomic masses. They are really what? Average relative atomic masses. Okay, fine. How to find out this average relative masses? That is very important. Any element you take, most of the elements in the periodic table, most of the elements in our periodic table exist in the form of isotopes. In the form of isotopes. Isotope means, already we have discussed, same atomic number but different mass number. For an example, if I take chlorine, right, the chlorine is available in the form of two isotopes. They are chlorine 35 and chlorine 37. Means these two are the same atomic number, but one is having mass number of 35 and other is having 37. Means the chlorine in the nature, it is available in the form of these two isotopes. Then how to find out the average atomic weight of this chlorine atom? Average atomic mass. So for that, two things we should know. One is the relative abundance of chlorine 35. For an example, chlorine 35 in the nature, the relative occurrence is 75%, and the chlorine 37 is 25%. This is called as relative abundance. Now, by using this formula, average atomic mass is equal to m into A plus n into B by m plus n. Right. By using this formula, here m means what? The relative abundance of a particular isotope, that is 35. A is what? Mass number, 35 you should take. By substituting all these, we can find out the average atomic mass. This is how we can find out the average atomic mass of elements available in the form of isotopes. Right, let me take one question here. For example, in this question, they have given us, right, boron has two isotopes. One is boron 10 and another one is boron 11, whose percentage abundances are 19.6%. Means boron 10 is available 19.6% and boron 11 is available 80.4% respectively. Then what is the average atomic mass of the boron? Now which formula we should use? The same formula we should use, right, with respect to boron. What is the m value here? The m value is 19.6%. When A value is 16, this is with respect to boron 10. That means the boron 10 in the nature is available with its relative abundance of 19.6, whereas the boron 11 is available in the nature with its relative abundance of 80.6%, 80.4%, and its mass number is 11. Now substitute here, the mass number is 10, right? Substitute average atomic mass. Average atomic mass is equal to m, means 19.6 into 10 plus 80.4 into 11 by the sum of the m plus n values. Always it is obviously 100%. Right. On solving, you will get the average atomic mass of boron. The average atomic mass of boron is 10.8 approximately you will get. This is how we can find out the average atomic mass of any element which is available in the nature as isotopes, right? So this is how we can find out. Next, if you go for here, the examiner may twist the question. Means how they can ask the question means this time they can ask. So we know very well that boron is available in the form of two isotopes, that is boron 10 and boron 11, right? So they will give this thing, and they also give that the average atomic weight of or average atomic mass of boron. How much? Approximately 10.8 they have given. Now what we should find out, the examiner will ask you find out what is the relative abundance or occurrence of boron 10 they can ask, or boron 11 they can ask. Then how to do? Means in the previous question they have given the relative abundances and you need to find out average atomic mass. And in this question they have given the average atomic mass and we need to find out relative abundance of a particular isotope. Means reverse. The question they can ask like that also. Then what to do? We know the formula. Average atomic weight or average atomic mass equal to what we can write. I don't know the relative abundance of boron 10. Let it be x. If it is x, compulsory it should be 100 minus x or not? Because we know very well that the sum of these two abundances must be equal to 100. So if it is x, it must be 100 minus x. Substitute x into what is that? 10 plus 100 minus x into what is that? 11 by 100. And what is the average atomic weight that is given in the question? 10.8. To it, 10.8 is equal to, right? So 10x plus 1100 minus 11x by 100. Do cross multiplication. If you do cross multiplication, what do you get? Tell me. 10.8 into 100, which is equal to 10x minus 11x plus 1100. Do it. Here 1080 you will get, and here 1100 minus x you will get. If this minus x comes this side, it becomes plus, and if this plus 1080 goes right side, it becomes negative. 1100 minus 1080, so x is equal 20%. Means the relative abundance of boron 10 is 20%. Then what could be the relative abundance of boron 11? Obviously it is 80%. This is how we can second model. So based on this model, here I will give one more question. You just look at this question. Look at this question here. Right. Chlorine occurs in nature as a mixture of chlorine 35 and chlorine 37. Means the two isotopes I have given. Their average atomic mass also given. How much? 35.5. The average atomic mass of chlorine also given 35.5. Now what we should find out? The percentage of abundance of chlorine 35 should be found out. Same formula, same method we have to use again. What is the formula? Average atomic mass. Average atomic mass is equal to what you can write here. Let it be first one thing, 1 minute, I'll explain. Right, what they have given in the question? They have given chlorine 35, chlorine 37, and its average atomic weight 35.5, and we have to find out percentage of abundance of chlorine 35. Now we don't know what is the chlorine 35 relative abundance. Let the percentage of chlorine 35 be X. Let the percentage of chlorine 35 be X percent. Then what should be the 37? It is 100 minus X or not? And apply the formula. Average atomic weight is equal to X into 35 plus 100 minus X into 37 by 100. What is the average atomic weight that is given in the question? 35.5. Substitute 35.5 by 1 I am taking, and here 35x plus 3700 minus 37x by 100. Do it. Cross multiplication. Then what do you get? Tell me. Here 35.5 into 100, which is equal to 3700 minus 2x. Why 2x? 37 and 35 minus 2 you will get. If this minus 2 will come here and this total value will goes to here, then what do you get? 2x is equal to 3700 minus 3550. Now x is equal to 150 by 2, that is 75%. If it is relative abundance is 75, what about the 37? It should be 25. That we have done. So this is how we can find out the average molecular weight. Here for this average molecular weight, so without applying this formula, I will go with one shortcut method. The shortcut technique is very important. What is shortcut technique? It is very important. So very simple. How many isotopes we have? 2 isotopes, chlorine 35 and chlorine 37. Chlorine 37. And whose relative abundance you have to find out? Chlorine 35 relative abundance is to be find out. And what is the average atomic weight they have given? Average atomic mass is given as 35.5. This method is called as the number line method. It is very famous in mathematics. What is this? Very simple. Here, percentage of, right, chlorine 35 equal to, very simple, you take, always the denominator is the mod of atomic weight difference of 2 isotopes. Atomic weight difference of 2 isotopes, the mod value. So here what are the atomic weights of 2 isotopes difference? 37 minus 35. I am taking in the denominator 37 minus 35. In the numerator always average atomic, the mod value of average atomic weight, that is 35.5 minus. So whose percentage is to be find out here? Chlorine 35. And here its opponent atomic weight should be taken. What is the opponent of chlorine 35? Chlorine 37. You have to take 37 into 100. Then what do you get? Here 1.5 by 2 into 100. So you will get 75%. You have got or not? Do you all understand number line method? Right. It is very simple. In a mixture of two compounds or two components A and B. Right. The percentage of A is equal to, right, average atomic weight minus atomic weight of B. Opponent we have to take, because you are finding the percentage of A. If you are finding B, you have to take atomic weight of A. And here mod of atomic weight of A minus atomic weight of B into 100. So this is a shortcut method which is also called as a number line method. So these are the basic concepts which are very useful for our further chemistry topics. Thank you. And in next video we will start atomic structure. Thank you so much, and we will meet again in our next video. Thank you. Please subscribe and share, like this video. Thank you.